Well, hello friends. Today we are going to work on the RPC stuff again. So let's see where we left off. So if you've seen the other stuff, the other videos, then we have a tool called RPC Dump that allows us to connect to a remote PID. 15 in this case was the launcher. And so we also have the inspector tool, which we can also use to connect to a remote PID, and it shows us the different C objects and their properties. In this case, this is the launcher app that we're looking at here. And so here's what we see. So the way that this works right now is that every program that has an event loop, like a C event loop from libcore, it exposes itself through an RPC socket in the temp directory. So if we go here, we can see them. It's just rpc.pid, and you can connect to these by opening them as a local socket, and then the only thing that will happen is that when you connect, you'll get a JSON dump of all of the C objects in that program. But today, I thought that we would improve this a little bit and have it not just dump when you connect, but it would actually keep the connection alive and let you send commands so that we can do something more than just dump it. Because ultimately, I would like this thing to be able to be live so that we can move this around and you could see the changes reflected here and stuff like that. And also that you would be able to do like remote method invocation. Whatever else we can think of. But the first thing we're going to do today is to just make this command-based instead of just having it dump on connect, because like when you connect to it, it will just dump everything and then disconnect you. So I'll show you what that looks like in the C event loop code. So here is the RPC server. So it opens it up. First we create the file name like this, unlink it if it already exists, and then we have an RPC server, which is just a C local server. That's a convenience object that implements a local socket server. So it listens on this path, and then we have on ready to accept, which this callback here or hook will get invoked whenever there is someone connecting to us. And then what we do then is we just call accept, which will give us a socket object. And currently, as you can see here, we just accept it, and then we iterate over all the objects and create a JSON representation of them, and then we write that to the client and then delete the client, basically. So delete later just means like delete next time you get to the event loop. So we're going to need to do something a little fancier here. So I guess we're going to want to have some kind of an object that represents a connected RPC client. Maybe we'll just sketch it out here. We'll call it RPC client, maybe CRPC client. I don't think this is going to be a public API. It'll just be an internal thing in here. So maybe we'll do this, although we can have it inherit from C object. That would be convenient. Public and private. Okay. And RPC client. And I'm thinking the way that this would work is that he will have the local socket as a reference member, and that's how we'll construct him. Like this, and sockets, socket, and then we'll do add child socket. So the C object model is a little bit strange. It's Qt style, which means that we use naked new and then parent objects on their children. So instead of using a smart pointer here, we do add child, which means that the local socket becomes a child of the RPC client, which is a C object. And then We just need to take care to delete the RPC client when it is time. So let's see. Here we'll do something like on ready read, I guess. On ready to read. What do we want to do? So I guess we'll fetch the request from the socket. So we call read all, which is convenient, just gives us the whole packet available in one byte buffer. And it will return a null byte buffer if the socket has disconnected. So then we can just conveniently do delete later and return. Otherwise, we're going to have to handle this. So I guess the easiest thing would be to use JSON for this, actually, because then we don't need to come up with a custom data format. So we'll just include ACK JSON value, maybe object, or probably actually, I guess I already had those. I didn't need those. Yeah. So here we can just do JSON request JSON is, or request JSON is JSON value from string request. If request JSON is object, if it's not an object, then we'll do this. Maybe we should say something here. So RPC client disconnected. RPC client sent invalid request. Yeah, and then, okay, so here we know, now we know that we have a JSON object, so then we can just call some helper for this, like handle request JSON dot to as object. Yeah. Then we'll put that down here. Call it request. Okay. And maybe the easiest thing would be to just have a request. So I'm imagining an object that just has a type field. So let's see, auto type is request get as string or nothing, and then if type is null, then say invalid. RPC client sent request without type field, and we'll just ignore it, but it's okay because it's a JSON object, so we'll just ignore it. Okay, and then if type is equals to, I guess we can call the existing stuff, we can call it dump, and we'll do what we were previously doing here. So basically iterate over all the objects in the program and then just send them back to the client. So I guess like that. And then down here, when we get the client socket, we can just do RPC client from client socket. Let's assert that we're getting a socket here. I should really be switching these to smart pointers. I just keep postponing it because I wanted it to be like Qt originally, but it is such a flaw of Qt that it doesn't use smart pointers more, and I have to go and take care of it, but not now. So here we'll return. So we need to disconnect in some cases. So here this will disconnect, but maybe we should have a way for him to disconnect voluntarily. So we'll say like close, delete later, return. And I guess we could have something like identify, and we can make ourselves a little response here. So like JSON object socket, right? String, and then I guess it would be something like object set. We'll send our PID and our process name. But we have some kind of get process name. Yeah, right. How does this work again? Oh, it's just a buffer and a buffer size. And we have to do the buffer thing. Yeah, okay. We'll just do the usual. Get a buffer. And if get process name buffer size of buffer is greater than or equal to 0, then set process name to buffer. These objects process. You want to create a null value, yeah, like that. Okay. And we'll return. Okay, and then let's see if we can get the RPC Dump tool to connect and send dump, basically, or send something else. So here in RPC Dump, which is just a very, very simple program that just has an onConnected, on ready to read, and then it just connects and executes these hooks, or calls these hooks as appropriate. So when we get connected, then we'll have to send a request. So we'll build up a request. We're gonna need a JSON object and value. Maybe I should make a convenience header that includes all the JSON stuff. Set type. Let's do identifier first. See how that one comes out. And then we'll do socket.write request to string. Okay. Get process name was not declared. Well, why is that? Get process name. It's in uni.std.h. Oh, but I'm not in Serenity here. We're also building C event loop as part of the host tools. So this stuff is actually gonna have to be Serenity specific. So we'll do this. For now, there's probably some way to get the process name on other systems too, but I don't want to mess with that right now. So, boom. It's kind of nice to make use of ACK and libcore in the host tools. So the host tools are used to build the IPC code generator and the Visual Builder form code generator. And I would like to use them for more stuff, and we will over time, but one thing at a time. Okay, so RPC Dump 15 doesn't tell us anything. RPC Client sent request without type field. Did we now? Oh, look at that. That's a little mistype. One thing that's annoying about working on the C event loop code is that we basically have to rebuild everything. So here's another situation where having shared libraries would be nice. But I keep postponing working on shared libraries because, you know, it's convenient, but it's not like blocking anything in particular. That's what I thought about thread local storage too, but then I realized that it is blocking everything or that I want to do with threads. So last weekend I had to go and implement TLS. But anyway, let's see what we're doing here. Okay, so that's the identify command. Response looking good. Then let's go in RPC Dump and let's just send the dump command like we were. Dump, and down here, I guess we'll just disconnect after we get all the data. Put char, blah, blah, blah. Yep, let's just disconnect after we have it. So maybe let's try disconnecting with the close method. So let's close. Just to see if that works. And it closed us. We got broken pipe. Oh, that's a little weird. Why are we getting broken pipe in RPC Dump from right? Maybe we can just exit here. We'll just quit. It doesn't have to be fancy. Fancy stuff has to go in the other GUI app. The inspector. Okay, so that's looking good. Now let's go in the inspector code and see how the hell do we do this again? Oh yeah, we have this remote process object that connects to the remote socket like this, or the local socket rather. Then on connected, let's just send a dump request just to keep things working the way that they were before. Socket right, request to string. All right. Apps. Oh, this is a dev tool. Sync and run. And let's connect with the inspector. Boom. See, we can actually see the RPC client here too, with the local socket. It's kind of neat. Or that's very, very neat. Actually, I love that you can see the connection from the inspector to the other program. So I guess it would be very good to identify these requests, so they probably shouldn't just be called like dump, but rather like, I mean dump, type dump. It's not the end of the world if it's called dump maybe, but dump objects, we'll call it dump objects. And get all objects. Yeah. And identify, and this one we can call close, or even disconnect. Close is fine. Or no, disconnect. Disconnect, because we don't want to like close the, imply that we're closing the program or something, but we'll disconnect like this. Okay, get all objects. And then we'll put that in the response, so that we know what kind of response we're receiving. Otherwise, this would get very confusing. So let's say response response.set type get all. I mean, actually, we'll just do this, and then we'll send the response set objects with objects. Okay, and we should do the same thing for everything, I guess. So same thing with these. Let's type actually, this is the response in this case, so maybe we should call it response and type is type. Okay, and here we don't need to respond to disconnect, that's fine. But then when we do the get all objects, we should, I mean, here we'll just dump whatever we get, that's fine. But in the remote process program or class, we have to actually look at the response. So we're not going to be getting an array immediately here, we're going to get an object. So we'll assert that it's an object, and then we'll say response is JSON value as object, JSON, and then that's the response that gets objects as array. And we'll do assert, or no, hold on, if response get type equal to get all objects. String or empty. Then handle get all objects response. And we will just take all of this gunk right here and do that, and add him here, and we need JSON objects, so that's in the ACK namespace. I'm going to try to avoid including stuff that I don't need here, but JSON object, Try to dodge the include. Okay. And then I think we're good. Else if response get. Oh, let's do auto response type. Do this. If response type is null, then no, just return. Ignore it. Return, and otherwise, if response type identifier. We'll make a little guy for that one too. I think that would be nice. Okay, and then here actually we need to, or probably this is okay actually, but handle identifier response. Okay, so let's see, int PID response get PID dot to int assert PID and PID. We should just assert that we connected to the thing we think we connected to, right? Because we have the PID that we connected to, so this just helps us verify that we're in the right, we're talking to the right thing. And then remote process name, or just process name, I guess, is response get process name as string or empty. Okay, actually we'll do this. Let's store that in a string, and then we can have it like this. Okay, and then maybe we'll have a hook here so that we can hook this on update. I think that would be helpful, because then we can actually invoke that when the name changes or something changes. And we'll just do this whenever something changes. Okay, and then when we get connected, I'm going to send not just a get all objects, but I'm also going to send an identifier request. Which probably make some convenience helpers for sending requests and stuff. But yeah, so we'll send an identify and then immediately get all objects. And then so who creates this thing? Remote object graph model inspector main. Okay, so here we do this, and then I think we'll do something like on update. And here we can do something like window set title if remote process name is not null, then we'll do that. Yeah, and then that will be remote process name, characters, and remote process PID. I mean, we know the PID, but I'll just have one here as well, just cause. And you don't like this because too many arguments. Oh, of course. Sorry about that. Let's see how this goes. Or actually, I feel like I have to rebuild more stuff. because I was changing the name of all the RPC types. So hopefully we'll get the window title. Hopefully the inspector will just work, and the window title will reflect the name of the thing we connected to. Look at that, launcher 15, but we don't get the remote objects, so something didn't go quite right. Connected to page 15, title set to inspector launcher, new line, oops, I fumbled that, need a new line there. Connected, okay, blah blah blah. But why doesn't it react to get all objects? Am I even sending it? I feel like I am. Let's see what we get on the other side. Oh, actually, we can test if RPC Dump still gets. Okay, so how does that look like? Type this get all objects. Oh, we don't have less. We have more of them. Objects. Yeah, that looks good. So why don't we get it? Let's do this. Incoming RPC request. Type is type. Look at us. I just want to see that we actually get both of the requests on the RPC server side. So incoming RPC request identifier, but we never get the other one. Well, why is that? Is it maybe bundled together? That would be a bit weird. I wonder if it's bundling these. It might be that they end up in the queue together. We may have to marshal them a little bit smarter than just text. Because I think right now they just end up in a buffer together. So let's see. Let's marshal them a little bit smarter. We'll just put the number of bytes in the object following. So let's see. Socket right. So send response. And we'll put that in a helper. And it'll be like this. Send response. Const JSON object. Socket right. And then let's do U32 length response string serialized to string, and then we'll do serialized length socket right length size of length. And then we'll do serialized Q8. Okay. Maybe it was okay to use int here too. Maybe it's okay to use auto. Yeah, that's fine. I32. Okay, and then we just have to make sure we use send response. Response. Okay, and then we have to do the same in the client side. So we'll do send request. And this will be remote process and request. Okay, and let's just do the same exact thing basically. Okay. And then we have to deal with the incoming stuff. So this will be a little bit different. Instead, we'll do like, I guess I32 length, socket read. Assert that it's the size of the length. Okay, and then after that we'll do read. What kind of read function do we have? Read max size. Yeah, right. So then we'll read exactly that many bytes. Okay, I think that's good. And maybe we can do the same thing in the event loop. Instead of read all, we'll do read the length, and then if in red is 0, then it's EOF. So we gotta handle that. Gracefully. And length is like this. Wait, no, not that. Request is this. Okay. It doesn't have to be perfect because they're just, you know, my own two processes talking to each other. But I guess this could kind of work, because then the idea is that it's on ready to read. He'll just get called again next time we're in the event loop. Oh, shit. It didn't really go the way I wanted. Got a null dereference. Look at these helpful messages. How cool are they? All right. Ooh, looks like it might be recently freed memory. It's even more helpful. Get all objects response. So what went wrong here? Title set to. So we got the identifier response probably. Then what? We died in inspector. So this is the lambda calling handle get objects response. And why are you crashing, my friend? Can I maybe add her to line you? Dev tools, spectrum. No? That would be too easy. Okay. Let's just do it the hard way. Okay, so what's going on here? We're right after a vector at for an assertion, and there's a malloc of all things. I guess that's inlined from something. Remote object constructor. Okay, so we're constructing a remote object. So we're here. Okay. Let me go ahead and dump out some more stuff about what was happening here. So, no process. So I can read that. Okay, and we've got packet size, length, and read that many bytes. Guess we can also dump out JSON response, and then here we'll just dump out the JSON value. Wouldn't that be nice if we could do this? We can't do that? Okay, 2 string then. Good enough for me. Okay, then what the heck happened? Got JSON response. And read that many bytes, blah, blah, blah. Okay, so there's something else going wrong. Get all objects response. Object. I don't see anything obvious that we're doing wrong here. Should be non-null for a vector. No. Remote object. So what is wrong with this input? As array seems to succeed because this assertion is not firing. Object array values. value as object. And is there something particularly wrong with this? Let's just put it here, do JQ. How do you do this? Oh, wait, that didn't turn out right. Wait, why not though? I selected everything, but just because it's not all on screen. Come on, mate terminal. Alright, alright. So this is looking pretty normal. Everything is an object and has an array called objects inside of it. And we know that we're here, blah, blah, blah. Okay, this is going to be something silly, I guess. So is that this pointer is screwed up or something? I don't know, I'm a little lost here, so we're just going to printf debug our way out of it. See what's going on. Blah, blah, blah. And little gour, adding a value, and then it falls apart in the first iteration. Okay. So read from address goes wrong. All right, maybe we should just look closer at that piece of code. So what are you actually trying to read, bro? Call debug log stream. Value is object. I feel like we're right after the debug log stream here. Comparing it to 8. That's 7, but we're in user space now, so that would be an 8. Actually, maybe let me switch over to user space. User land. Boom, 8. Okay, so it's trying to read the value field, and that fails because this object here, calling response get as array. Oh, what's going wrong with that? Response get gives us a value. And then we are just doing as array on it, so it doesn't persist. So it's a little unfortunate, but we have to actually get thing out. I see. So this is a sadness of the JSON API that this thing disappears out of scope here. So we have to actually make a local copy of it. Objects, response get objects. We can definitely do better with this, but it is what it is at the moment. So fix me. No good if we didn't have to make a local copy of the JSON array value here. Because, yeah, so we were just creating that temporary, taking the address of it, and then forgetting it. Or deleting it, rather. So here we are. We are connected. You can see the identifier response that showed up here. It's pretty cool. And, oh, that did not go well. Why does it crash when we do that? Launcher dies, and CI device read. And the RPC client constructor lambda. So I guess we are read from a null pointer. Where are we reading from the null pointer though? CI device read. That's the what's that overload? Mem copy. Oh, look at that. This isn't right. So if this thing fails, then we shouldn't try to mem copy from it. So we'll say freebuffer is null. Return 0. Yeah. So that's a nice little patch to do on its own there. Libraries, the core CI device. CIO device. Read, wait, int overload should return null 0. 0f. Okay. Let me connect the inspector to the launcher and then close it, and the launcher is still fine. Yeah, that's good. And RPC client disconnected. Yeah, everything here looks very good. Great. Should remove these adding value things. Okay. I think, actually, let me just check what RPC Dump says right now, because I don't want to break it. RPC Dump 15, it's broken. Yeah. Oh, it's insanely broken, actually. What are you even trying to do? Create uninitialized. It's trying to create a humongous buffer, and that's very silly. And then we die in the kernel. We should probably just fail here instead. Okay, malloc implement. Anonymous VM object. Why does that get so big? What are we trying to create here? Fixed array. I guess we're trying to create a ginormous thing. So that's a whole other problem. I'm not going to deal with that right now. But yeah, mmap should definitely fail gracefully in this case. Anyways, what is it that we want to do now? Fix RPC dump so that it encodes the little request thing with the number first. So socket right, request serialized request to string, and then I32 length, serialized length. Size of length, and then send a serialized request. Okay. Oh, it's not called toString? Oh, right, yeah, because it's already a string. So I guess we're not getting like a whole lot of new functionality in this video, but we are definitely improving on the architecture of the inspector and the RPC mechanism, because now we'll be able to add all kinds of commands next time that we work on this. So it's pretty cool. This is the only new feature, only new visible feature is seeing the process title. Okay, so patch review, right? What did we do here? RPC Dump has been extended so that when he connects to the RPC server, then he will send a get all objects request. We should make some helpers for this, but we didn't right now. Anyways, he just sends that, and then he will quit voluntarily when he gets a response. That's fine. And then here in the C event loop, where we listen for the connections, we now have an RPC Client object. We may need to move this to a separate class at some point, but right now it's fine to have it here, I think. So he just listens for commands in JSON encoded packets, basically, preceded by a 32-bit length, so that we know how many bytes in the packet. Okay, and then we decode it, and then handle it differently. So the previous send all object stuff goes in the get all objects request, and then we have identify, which sends over the PID and the process name if we're on Serenity, which we are, obviously. Okay, yeah, nothing too crazy here. And then in the inspector, we added this little callback here on update, so that we can update the process, the window title of the inspector if we've learned the process name of the remote process. That's nifty. And of course, this will also get called if the remote object graph is updated, but we don't take advantage of that yet. We will eventually. Here are just the changes to remote process. We separate out the handling of these responses into functions so that we can deal with those. And yeah, so when we connect to the remote process, we immediately send identify and also get all objects to the other side. We need some helpers here too. And then the previous code for handling the dump goes in get all objects response handling, and then of course also handle identify response takes care of response to the identify request. Okay, so yeah, I think we have something pretty good here, so we're just going to commit this and say inspector plus load core plus RPC dump. Rework the RPC stuff to be command or request response. RPC clients now send JSON encoded requests to the RPC server, and the connection also stays alive instead of disconnecting automatically after the initial object graph dump. JSON payloads are preceded by a single host order encoded 32-bit int containing the length of the payload. To begin with, so far we have 3 RPC commands. identifier get all objects and disconnect. Adding more of these as we go along. Cool. Cool. So let's see that one more time. Let's connect to something else also. Maybe we can connect to the Doom. See if we can see anything. Should be able to see something there. So it's bit 23. Just a little bit sluggish. Oh shit, we ran out of kmalloc memory. Wonder why. Oh, wait. Oh, it's because I have to recompile Doom. Let me rebuild it. Just takes a moment. Because of static linking, then he has, like, the Doom program has this old version of cEvent loop, so it doesn't know about how to respond to these commands that we're sending. And then we have that little kernel bug that fills up the heap, which we have to deal with eventually. But right now we can just sidestep it by rebuilding Doom. Because I want to see what Doom looks like in this thing. Of course, it's not gonna know anything super interesting about the Doom game. We could add that sometime. Somebody actually suggested that in a YouTube comment that we could show monsters and stuff in the inspector. And, you know, that's a funny idea for a future thing. Wait, I thought I removed that stupid thing. Adding value. Okay, maybe I didn't rebuild the inspector. Anyways, oh shit, wait, I connected the launcher. I'm stupid. PS. Wow, look how slow it is. Oof. Alright, let me see what's in the Doom process. We are connected to Doom. Look at that. We have a timer. I know that's the event loop timer that I made in the Doom port. And here's a connection to the Windows server, probably. Here's the RPC server, and here's the RPC client. And then there are no more C objects, unfortunately, but it's still cool. So maybe we'll play with that in some other video. Right now, I think we're good. So yeah, that's gonna be it for today's video. So if you made it this far, then I thank you for watching and for subscribing and hanging out, and you know, leave a like if you think something is interesting, because then I know that it was interesting. Helps me understand the audience better, I guess. And otherwise, I'm just gonna say I will see you next time. Bye.